Hey everyone. In the last video, we talked about what a solution to an equation is. This time, we're going to be working on actually finding solutions. So, the type of equation we're focusing on in this chapter is called a linear equation with one unknown. And a linear equation with one unknown has one variable, because of course it does, and it can be written as ax plus b equals 0, where a and b are real numbers and a is not equal to 0. So here's some examples. We have this first guy, 3x plus 2 equals 0. In the second equation, we have negative 5a plus 9. The variable doesn't have to be x, it can be anything. So long as you have one variable, you can write it this way. The third equation, 8y minus 10 equals 6y, is not explicitly written as ax plus b equals 0 because there's something other than 0 on the right-hand side. But it's okay because it can be written that way if you subtract 6y from both sides. And last up, we have 4x equals 15. Again, not explicitly written as ax plus b equals 0, but if you subtract 15 from both sides, it will be. So those are some examples. Let's look at some non-examples. 1 plus 2 equals 3. There's no variables, so definitely not a linear equation. And in the second equation, the power of x is 2. And if you look at the form we're supposed to write it in, ax plus b equals 0, there's no way to change that to get rid of that exponent. So that is not a linear equation. So let's look at a general strategy for solving linear equations. In step 1, we're going to be simplifying each side of the equation as much as possible. So you could have to use the commutative property, you might have to use the associative property, distributive, any of the things we talked about at section 1.5, also PEMDAS. After you've simplified, you want to collect the variable terms on one side of the equation. You can do that by adding or subtracting to both sides. After you do that, you want to collect all the constants on the opposite side of the equation. You want to simplify again, you need to. And then you want to divide both sides of the equation by the variable's coefficient. And what you're left with is the variable equal to the solution. So for some examples, we have negative 16 times 3n plus 4 equals 32. First step is always to simplify both sides of the equation. And I can simplify something that has a variable in it, like this, by applying the distributive property. So I take negative 16 times 3n, and negative 16 times 3 is negative 48. And then negative 16 times 4 is negative 64, which we can write as subtraction. Right-hand side of the equation was already simple, so we don't have to do anything to it. All right, now the next step would be to collect all the variable terms on one side. They're already on the left-hand side, so we don't have to do anything. The step after that would be to collect all the constant terms on the other side. So what I can do is add 64 to both sides. So when I add 64 to negative 64, I get 0, which means the left-hand side is just negative 48n. And 32 plus 64 gives me 96. Last step is to divide both sides of the equation by the coefficient of the variable, which is negative 48. And finally, we have that n is equal to whatever 96 divided by negative 48 is, -2. And the wonderful thing about doing these problems is you can always check your answer. You go back into the equation, the original one, and substitute -2 in for n, you should get the equation that's a true statement. All right, for another example, we have a fraction this time, a little bit spicier. So I'm going to start by simplifying and distributing this 1/5. So 1/5 times 15 is going to give me 15 over 5 times c plus 10 over 5. And then on the left-hand side, I don't have to do anything. And now I'm going to simplify. There's no more fractions. Our problem's gone from spicy to pretty mild, actually. So the next step is to collect all of the variables on one side of the equation, which we can do by subtracting c from both sides of the equation, or you could subtract 3c from both sides. Either is okay. And then we subtract 2 from both sides to collect all of the constant terms on the other side. Lastly, we divide by the coefficient. And we're left with c equals 5 over 2. The next example here has a distributive property on both sides of the equation. It's a little bit more work to do. So upon distributing this 2 here, I'll have 2 times 5, which is 10, and then 2 times -3y. So we'll have a -6y. And on the right-hand side, I'm taking -9 times y, which gives me -9y. And then -9 times -1, which gives me +9. All right, now we collect like terms. So we have 22 minus 6y equals 9y plus 7. The next step is to collect all of the variables on one side of the equation. So let's do that by adding 9y to both sides. And -6 plus 9 is going to give us +3. And I have to subtract 22 from both sides because I want to get the constants on the other side. So that 3y is equal to -15 divided by the coefficients. And we're left with y equals -5. Last example for this video looks even bigger than the previous one. So when you first look at this, you're going to see lots of grouping symbols. So at first, we want to simplify everything in this grouping symbol, which means we have to apply the distributive property. Over on the right-hand side, we also have to distribute. So I haven't done anything to the 3 or the -14. And you want to be really careful. You don't want to try to do too many steps in your head at once. I'm like really clumsy and really prone to making mistakes. So I try to do as many steps as possible. All right, 2 times 15k is going to give me 30k. And then 2 times -6 is going to give me -12. 8 times 3 gives me 24. 8 times -5 gives me -40. We want to simplify again by collecting like terms. So the like terms on the left-hand side would be this -14 and -12. And adding together gives me negative 26. The like terms on the right-hand side are 24 and negative 24. So I'm really just left with negative 40k. Now I have to distribute again. Gives me 90k. 3 times negative 26 gives me negative 78. And on the right-hand side, I have negative 40k. I want to collect all the variables on one. All right, now I have to collect the variables on one side. I'm actually going to do that by subtracting 90k from both sides. And on the left-hand side, I'm left with negative 78. On the right-hand side, I'm left with negative 130k. So you see, by doing that, I don't have to do anything else. I have one side with a constant and one side with a variable. So now I divide by coefficients, and I get k is equal to 78 over 130. Does that simplify? No. 3 over 5. So our final answer is that k is equal to 3/5. Yeah, so that about wraps it up for this video.